All right, so our problem statement was, how long will it take for our robots to get to Disney World? Okay, so someone, Jillian, estimated that it was probably about 1 foot per second. If our robots would travel at 1 foot per second. And then we also needed to consider the motor power, because some robots might travel slower or faster depending on the motor power. Some are set to 75, some are set to 100. And we also talked about graphing and how when you first start out, the robot is accelerating. So the rate of acceleration is actually not constant. So you have a rate of acceleration here, but at some point, your robot is traveling at a constant speed. So your graph of distance versus time becomes a straight line. Okay? Let's see, then we talked about accuracy, and there was 3 things that I'm going to quiz you on at the end of class to figure out how can we get better accuracy. Instead of timing our robot on 1 tile on the floor, which is 12 inches, we could actually time it over about 10 tiles or even longer. Somebody said even longer, to get an average speed, and then calculate our speed and our time, or our distance, to calculate how far it would, or how long it would take to get to Disney World. And we know that our distance is 417 miles based on Google Maps. So one way we could get a more accurate time, the one consideration was a longer time, taking the average. The next consideration for accuracy was that we didn't want to start our stopwatches right away because of this slope and this variance in acceleration. And then there was one more. What was it? I think that Liam brought it up. Oh, the fact that we're not always accurate when we hit the start and stop button. We're not always accurate on hitting on when we started. So we want to take a number of trials in order to take the average of those number of trials and get a more accurate estimate of our speed.